In this demonstration we show the usage of our Ethercat library for Labview for a PID control application. We use two back-off Ethercat terminals to perform the speed control of a brushless DC motor with encoder. Our demo setup consists of a brushless DC motor with encoder. The back-off slave terminal EL2502 is generating a PWM signal to control the speed. To adjust the voltage level for the motor we use a MOSFET driver module. To read encoder signals of the motor we use an EL5151. The EL5151 is an interface for the direct connection of one incremental encoder with a 24 volts output. It provides the position and also frequency of the encoder. We will use the frequency to calculate the motor speed. The EL2502 is an PWM output terminal with 24 volts level. It works with a base frequency of up to 20 kHz. The Ethercat library for Labview comes with a set of predefined functions to work on the process data and the master cycle. These functions are executed in each master cycle in the real-time system. In our application we are running the master cycle with 1 kHz. So the PID controller is executed deterministically each millisecond. The PID function performs a standard PID controller calculation with optional filter on the process variable and anti-windup of the integrator. There is one function to create a PID controller object and multiple update functions to set the state, set point and parameters. The PID controller can be enabled and disabled. When disabled, the outputs can be set from the application. Our Labview demo software is using the PID controller data processing functions in the Ethercat library for Labview in real-time mode to control the speed of the DC motor. In the upper left corner we have the initial parameters to construct our PID. Below we have the control area to update the set point and the parameter. To the right the process value, set point and output is plotted. Here we take a look at the Labview block diagram. Using the driver libraries for the Ethercat library for Labview the programming is very simple. After starting the Ethercat master the PID controller is constructed with the initial parameters. In the process loop we continuously acquire the speed process value and PWM output. Here we see the updates of the PID controller to set the state, set point and parameters. Now we are going to run the demo application. For the DC motor we need to set the output limits of 20 to 100% PWM signal. Also, we enable the smoothing filter for the speed signal and the anti-windup. To start the DC motor, we need to set the PWM output to 100% for a short time, so it gets into motion. We do this by temporarily disabling the PID controller, to have manual access to the output. After this we can set the state to controller active with our PID parameters and set point. At this point we change in a couple of times the set point to see the reaction in time of our motor with the PID controller. Thank you for watching. For any questions or remarks, please leave a comment below or contact us using the communication channels in the video description.